So we have done the real depth and apparent depth, right? So today we are going to do some questions in which we are not supposed to assume the near normal incidence. Rather, the incidence angle will be finite, and we have to derive according to the ray diagram, not according to the formula that we have derived. So it's a very famous question. I think it's in SC
Sir,
Verma
what did
only.
you say right now?
Pardon?
Sir, you said something I could not hear you properly.
I said that okay, we have solved a question in which we assume the near normal incidence, right? And now, am I audible to you?
Yes, sir, now you are audible.
So what I said is that we have solved question in which we assume the near normal incidence, right?
Yeah, yeah.
Now what I'm saying is that it is not necessary that every time you will have the question based on the near normal incidence. So you may not be able to apply the formula which you have applied so far. So you have to do it from the ray diagram itself. Okay. So imagine there is a container like this, and you can take the height of container as h, and there is a coin. And this is A, this is B. And now there is a person who is trying to look inside the container at this end. So will he be able to see the coin? The answer is no, because the light ray is not going towards the observer from the coin, right? So the person can see only the corner and the above, right?
Yes, sir.
So to see the coin, he starts filling the water or some liquid in the container, and he keeps on filling till the instant the light from the coin goes towards the observer. Understood? And let me make it, this is capital H. So the question is, what is should be the H value such that the coin becomes visible? So you can imagine this way, like if the light ray will come this way along the green line, so because of reflection, it will go like this. Correct?
Yes, sir, it will go like that.
Which means it is possible to see the coin now.
Yeah,
At least you can say the coin can see the observer if coin is having the eye. In the reverse process, if the light ray will go this way, the chances it will reach the observer. So we would like to know that what is the height, small h, which can make this possible. You can choose this as x value, and if it is x value, this is the h height. So the remaining will be how much? This will be b minus x, and this will be
H minus H minus H.
so. If you use the Snell's law, you can add, let's say the mu is the refractive index, we can add mu sin I equals to 1 sin R. Okay. And also the R is kind of known to us. What is R value? If you look carefully.
Uh, yeah.
So tan R will be
B
A
minus
plus
X.
B, A plus B by H, which is also the same as B minus X by H minus H. Am I right?
Yes.
If you look at the bigger, the initial direction given, the green line. So tan R is known to us in a way in advance, which will give you a B minus X equals to H minus H by H into A plus B, which is entirely constant. So X is B minus like this. Let me expand it. HB HA minus HB. Anyway, so something like this will come. So this is not important. I mean, in the examination tool, you will get a very simple values, nice values. So we got X, and now we can use the business of mu sin I. What is sin I?
X. Sorry. X.
And 1 sin R. What is sin R? Because tan R is known to you, we also know sin R, right? So sin will be A plus B. And because we know X already, so you can square both sides. Invert it. There becomes, and if you divide, you get by mu square plus x square by mu square x square. And then you'll get x value from here after rearranging and all. And then you will equate these two x value to get to the h value, which is very cumbersome. Of course, there is no need to solve. What I'm trying to explain is that how to think about.
So how did you get the sin R value as that?
tan r is how much? What is sin r? P upon h perpendicular upon
Yeah.
hypotenuse.
Yeah. Oh yeah, sir. Sir, and
I,
then why did we just take, like, how to decide which triangle to take? Because there are two ways to take sine R.
yeah, so we have to eliminate the variable. So of course, one equation won't be sufficient, right? So I have a problem with x. So to get rid of x, I can use the triangle, the above triangle, because r is known to us in advance. Because r is known to us, so we can use the r5 value. And the r comes in two triangle, the big triangle, the small triangle, right?
Yeah.
So that gives us the x value, which is unknown. Understood?
Yes, sir.
Okay. So we can go to the next concept. So one question which is again very common is called the mirror problem. So a slab with a silver surface. Then put a question like, the moment you have a slab and if you put a silvering on one of the side, so this becomes a thick mirror. So it will act as a thick mirror, and if you want to draw the mirror diagram, you can do like this. Okay, so that's the whole idea. So now let's say if you have an object here. So the distance of object from the first interface is d, and let's say this is the observer. So observer will see himself because observer is trying to see through the mirror. So what will be the distance of image as seen by the observer? Can you guess?
So what is the distance of?
Find the distance of image with respect to observer. Okay, so look at this, how to go about it. Okay. First of all, who wants to see? The answer is observer. And what is the location of observer? I can say location of observer is air, right? The mu is,
Sure.
yes.
Sir, I got one thing like d minus t into 1 minus 1 by mu. So what did I get for that?
Pardon, you got
d
D
minus t into
minus,
1
yeah,
minus 1 by mu.
like this, right?
And d minus that, like d minus,
D is up to here, no?
yeah,
So first of all, the slab will give the see, the observer will not look at the mirror the where it is exactly. So where the mirror will appear, for anyone looking from the left side from the air, the mirror will appear here. See the apparent position of mirror, apparent position of mirror as seen by observer O, correct?
yeah,
And what is the apparent distance? We know this. It is T by mu.
yeah,
So for the observer, the mirror is here. So where the image it will form? Exactly D plus T by mu behind. Yes or no?
yeah,
So what is the distance? Can we say it is twice of D plus T by mu? Can we say yes or no?
yes, sir.
So this is the method one. I'll show you a few more methods. So there are many methods called method of interference. I mean interfaces. So let's analyze in a different way. This is the simplest way. Indicate. So here is the object, right? There are multi ways to interpret the question. And this will be the most difficult part if you want to master this idea. Let's see. Okay, so imagine that you're not shifting the object, you're keeping the object as such. Imagine from the point of view of mirror. So think from the point of view of what is the distance of object from the mirror?
T plus T.
What is the distance of object as perceived by mirror? How much you said?
T plus T.
No. The mirror is bounded by the medium called slab. So the mirror is looking at the object through slab, not directly, right? So you cannot see D. You will see T and you will see D apparent. And when you look from the denser medium towards the rarer medium, it appears farther, right? Do you remember this? No.
Yes, sir.
Anybody who remembers this?
Yeah, sir. It appears.
So if the mirror is looking at the object at this distance, what is the image position of the object as seen by the mirror or as seen by the person in the medium same as mirror? It's the same question. So any observer which is part of the mirror frame, it is like a frame of reference. So if I think of some auxiliary observer, O dash, so the O dash will look at the object O, which is at a distance t plus mu d away from the mirror. So distance of object in frame of medium same as mirror with respect to mirror will be how much? Tell me guys. T plus mu d, because the mirror is seeing. So for the mirror, the actual object is where? Look at this. For the mirror, the object is actually far away. And this is T plus mu d. So where the image will form? Same distance behind. So for the person in the mirror frame, what is the distance between the object and the image? Is this clear, guys?
Yeah.
But we want the answer in which frame? In the air frame, right?
Yes, sir.
So now there is something called the transformation of medium or frame. If you know the answer in one frame, you can find the answer in another frame. So transformation of frame. So observer one upon mu1 is same as observer 2. I can say calculation by observer 1. I'm just trying to create a kind of a generalized picture. Calculation by observer 2 by its own medium. That's how we convert the answer. So we know the answer by which medium? The mu medium, right? So our answer is twice of T plus mu d by mu is equals to the answer we are looking for upon 1. Do you realize this?
Yes, sir.
And you can see the answer is how much? You can see the answer same as before,
Yes.
but it's a very rigorous. I mean, we are doing in many steps. So how to solve, like how to apply the concept without getting confused? The answer is simple. You first decide that in which medium you want to solve. Then try to look at everything in that medium, and then whatever you will get the answer will be correct answer. Okay. Are you getting the point? How it is happening?
Yes, sir.
Okay. And the third method is, of course, the idea we have discussed already, the normal shift method. So in the normal shift method, if we have a, let's say, plane mirror, which could be replaced by a concave mirror or convex mirror as well, we can solve that question also. A slab position doesn't matter whether we are silvering the slab. We can think as a silvering of slab. We can think as a combination of slab and mirror, right? And then we have an object here at a distance d. Thickness t. So first of all, while going towards right, the object will shift towards right. Correct. So when the light ray will go this way, it will bend towards normal, and will go like this, and we have done this. So while going right, the object will shift where? So O will shift by delta n to a new position O dash, which the mirror will perceive as the object. Okay. And then mirror will create the image as per the last ray, right? The last incident ray. Understood? It's difficult for you to perceive. So for the mirror, the object is somewhere here, right? I hope you can see it. Can you see the apparent position of object as seen by the mirror?
Yes.
So mirror will form the image as per the O dash or O. How the mirror will form the image? As per?
As per O dash.
Correct. And therefore, the light ray after reflection will go like this. This is as per O dash. I can say I dash. This is the reality. What I'm drawing is the actual ray diagram, what is happening actually, how things are happening. And then after hitting this mirror, this slab again, the light ray will bend like this. And so any observer on this side, like if you are sitting on this side, you will actually see this ray. And this ray will appear to be coming from where? Not from I dash, but from this position. So your distance from O to I double dash is how much? That's the question mark, right? You're trying to figure out what is O to I dash. I double dash. So this is also delta n. This is also delta n, right? We know the shift value, correct? Hello, hello, hello.
Yes, sir.
So what was the actual distance from the mirror to the observer? This distance was t plus d,
Yeah.
if you remember. So the image, this is t plus d, and we're trying to get the answer. As per this answer, this is I double dashes. What is this distance from mirror to this thing? So I dash was formed for the shifted object. It must be t plus d minus delta n, correct? So this is how much? Can we say d plus t minus 2 delta n? Because it will shift like this by delta n value. Can you see that? Hello, hello, hello.
Yes.
So this entire length is how much? This is t plus d minus 2 delta n. So the
But I didn't
final,
understand the 2 delta n.
this is t plus d. This part you understand? The first part.
Yeah, yeah, that I
Now the first, now the mirror will form the image of O dash. How far is O dash? O dash is t plus d minus delta n away from the mirror.
Yeah,
So image will be exactly behind by same value.
yeah,
T plus d plus t minus delta n, correct?
yeah, till that I understood.
And then while coming back, the image will further shift here, right? When the light ray is going left, so it will again cross the slab and will shift like
Oh yeah,
this.
sorry, I got it now.
Understood? So the
Yeah, sure.
separation, what separation we are getting the answer? Twice of t plus d minus twice of delta n, correct?
Yeah,
So twice of t plus d minus twice of, and delta n is how much? T minus 1 by mu.
yeah, sure. Yeah.
Something wrong. The t term is getting cancelled. Huh? T plus t plus d minus delta n. Okay. So the distance will be d plus t plus d minus. What we're getting here 2t plus 2d minus 2t plus,
Sir, it's not, it's getting cancelled, but then over there also it's multiplying.
pardon?
The 2t is getting cancelled, but then over there it is
Yeah,
multiplying
yeah,
to
yeah,
get
fine,
2t by
fine.
mu, so it's not, yeah, it's
It's the
same.
same answer, no? Same answer.
Yeah, sir.
Yeah, yeah. Okay, I thought it's getting cancelled. Sorry. So you can see this is a real method, which is very rigorous, and you need to think a lot. But this is exactly what is happening. The first two method is like the way to get the answer without thinking much. So it will take some time before you actually master the idea, like how to manipulate things accordingly and how we see things. And the idea of change of frame is very easy. But the best way is like you stick to only one medium, because the observer medium is the final answer. Because if observer is trying to see object, I mean see the thing, then try to explain everything in that frame, you will get the right answer. If you do analyze in other frame, then you have to switch back to the original frame by concept of transformation of frame. Understood?
Yes, sir.
So many questions comes based on this. And if you know the method 3, the good thing is you can answer any intermediate question also. So because you know what is happening at every step. Understood?
Yes, sir.
So you have a Verma, you can solve many questions from silvering of slab question, which is already there. Now let's do one question. Okay. So now what we are doing is, so we have some observer here, and there is a fish in the pond, not pond, aquarium actually. This is, let's say this is aquarium. Aquarium with one of the wall of the aquarium is mirrored, like silvered, you can say. So you can see the aquarium, you can see the fish, you can see uh, the image also. Anyway. And the fish is, so question is find the relative velocity between object, the fish, and its image as seen by the observer on the left. And he is sitting in this air, you can see. So find the relative velocity of fish and its image as seen by observer. Okay. So try this out. I think T has nothing to do, but still I have given. So spend some time, think about it, do some mistake, then only you can learn something. So please. Okay, fine. Okay. So we have done the velocity analysis, right?
Yes, sir.
So how we write the velocity? So velocity in a medium which is not same as the object, how we write? So velocity of fish with respect to observer will be, now observer is at rest, so that's a good thing. It is simply v1 by mu. I should have written only v1. I'm writing v1. But okay, there are two medium I'm going to use. So what is the velocity of the fish with respect to the observer? So it's very common sense. If you think this way, you can call it x. So distance of observer from the interface is fixed. And always remember, every numerical value must be calculated from the interface, not from anywhere else. So what is the distance? I'm trying to show you from basic, very basic, which is not required. So what is the distance of fish? Let's name it differently. Distance of fish with respect to observer. What you can write? D plus x by mu. So what is the rate of change of this? And because the fish is going towards the right, so x will grow. So we can say this is v by mu. Is this part clear? Yes or no?
Yes.
Now, how far is the image as seen by the observer? You can also do in the same fashion. At any instant, the image will be how much? So the fish and the mirror both will shift towards the left, right? So where the mirror will appear for the observer? Or simply, what is the image distance of image from the mirror itself? It's the same now, because mirror will see the fish at the
Yeah.
exact same location, correct? So the distance of image as seen by the mirror is 2t minus x behind, but for the observer will be how much? By mu, right? You have to divide by mu. Anyway, so the whole idea is simple. Since mirror and fish both will shift by same value, so you can add the distance of image this is t minus x. So for you it will appear t minus x by mu, or I mean it's really lengthy to do that. So we know the distance of fish with respect to observer. What is the distance of fish image with respect to observer? Can you tell me? You just find the distance. Don't try to solve anything. How much you like. The mirror will be t by mu closer, right? The mirror will be t by mu, and the fish will be x by mu. So how much you will see the image distance? T by mu minus x by mu on the right side, correct? So the distance from here will be t minus x by mu. Okay, and this is t by mu. So what is the net distance from the observer? D plus t by mu plus t minus x by mu. That's how you can write. Again, this is of no use because all are constant. If you differentiate, it's called z dash. So dz dash by dt is how much? minus v1 mu. That's simple. No need to worry much. So image will go left. That's it. Logical. If object is going towards right, so image will go towards left. That's the only difference. So what is the relative velocity? So v relative will be how much, guys? Tell me. It is 2v by mu. And no need to do all this thing. I mean, you can do it by common sense that if the object is going, if you know the answer of the object, the image will be just reverse. It's a plane mirror. And then you have to take the relative of this two. Understood?
Yes,
Yes.
sir.
No need to do all these things. What you can do is just find the velocity of the object, which is v by mu. We have discussed, I think, in this part earlier. And then image will be reversed, and then you can just the relative will add up. Okay.
So twice, because then it will be behind the mirror. So,
No, no, if fish is going this way, then the image of the fish will go left. No?
oh yeah, yeah, you go towards it. Yes, sir. Good.
So, fish. How to do the fish? Like this. It will also appear to the observer by v1 mu. Okay, going left. And you can also replicate the EM in the medium on the left side also by same value. So you can imagine that mirror will create a medium image also on the right. And then you can replace the mirror and think about it. You can think like this. Not a very difficult question. Let me give you the difficult one. Not very easy, I can understand. It's not, but not very difficult as well. So now I'm changing the observer. So now I have two fish. Fish one and fish two. And both are in the different medium. And the right of the medium two, I am silvering. So I can make any one of them as the observer. So question is find the relative velocity of fish and its image. Fish two. Oh, fish two and its image as seen by fish one. That's it. Think about it and try to write not answer. Try to write a description because when you revise, you will have no clue how you have written the answer. So you have to write the entire description that how you thought, what was your thoughting, I mean, thought process, and how you arrive at the answer.
So can you show the previous page for me?
It's simple. You need not to get panic. Just think that okay, and how to transform the answer in a frame or in a medium which is different from the object, and then take the relative velocity as you do in kinematics.
Sir, if we know the V relative, then we can directly find the relation with V relative between the observer and this velocity.
Pardon?
So if we already know that V relative for the image and the for the fish, the image,
Yeah,
then we can directly find the
correct, correct. So
relative velocity.
mu one will also come into picture, right?
Yes, Newton also.
Because see, I mean, we are finding the image and its image. I mean, sorry, the relative of the fish two and its image, which means the v1 will anyway cancel out the value because v1 will not come to picture, but the mu1 will come to picture because the velocity of fish two as seen by one will be v2 by mu2 into mu1, right? Correct. This is the velocity of two with respect to one only. Now velocity of two's image, it will just reverse. That's it. And therefore the relative between these two will be how much? Sorry. So now if you find the relative, it will become twice. Done? I hope this is clear. Hello, hello, hello.
Yes.
Any doubt in this?
No.
Oh, fine. See, the idea is when you look at any object in a medium different from yours, you never see reality, you see the apparent value. Okay. And that is what you need to realize, that what is the apparent position, and if you differentiate that apparent position mentally, you will get the apparent velocity. So that's how you can think about it. Okay. So I think we can go to the next concept. We have done the apparent real, slab is done. So we can move towards the refraction from curved surface. Just let me check if something is left out. Oh, no, no, a lot of things left out. Okay, fine. Okay, so solve one question, a basic question based on real and apparent depth. So imagine there is an object which is stuck inside a denser medium, maybe like a tiny dot, a bubble in a glass, and the refractive index is not known to us. So this is 20 centimeter. Okay. Now object is seen from observer one, and it is also seen from the observer from the other side. Okay. So the same thing is observed from two sides, as you can see. The question is, if apparent position of object as seen by observer 1 and 2 are 8 centimeter and 10 centimeter respectively. No, 8, 6 and 8. 6 centimeter and 8 centimeter respectively, then find Ri of medium. So find the Ri, the refractive index. Question is clear?
Yes, sir.
Yes.
So do it. Got the answer?
Sir, 1 minute. Sir, I'm getting mu as 20/23.
How it is less than 1? Huh? So the 8, so the 6 is, if I say this is x, this must be 20 minus x. So
Yeah,
6
sir.
must be x by mu, and 8 must be this by mu. So 6 by 8 is x upon 20 minus x, which is like so 3 times 20 minus x is 4 times x. So 60 equals to 7x. X equals to 60 by 7, which is 6 mu. Okay. Mu is 10 by 7. Or you can substitute the x from here directly, and that's it. 8 equals to 20 minus 6 mu by mu. 8 mu and this one. Yeah, sometimes you can find x also. So 8 mu equals to 20 minus 6 mu. So the mu is 10 by 7. I hope this is clear.
Yes, sir.
So what you see is the apparent, right? You don't see the actual. So actually you have to believe, and then apparent you have to use to get the answer. I think
Sir,
you have
I
done.
did like the apparent shift plus x will be 6, and then the 20 minus x plus the apparent shift for other one will be 8. But I got the wrong answer.
No, so you get the right same answer. So you're at x minus, the shift will be x into 1 minus 1 by
Yeah.
mu, that's it. Which is same as x by mu. No? So you might
Oh,
have used the wrong value here, 20.
yeah, I wrote. Yeah.
Your slab size is x only. No?
Yeah, yeah, yeah.
That's the mistake.
I wrote the thickness.
Yeah,
So
yeah, that's fine. I got your problem. Okay. Let's talk about something called deviation. So what is the deviation? The bending, right? So if the light is coming like this, and it goes like this after refraction, So we can write a sin I equals, okay, that's not required. So anyway, but deviation simply means how much you have tilted or bent or turned from the actual path. So this ray has turned by delta. This is the deviation. And therefore, the deviation connector here is del equals to, can we say I minus R? Hmm? Can we say yes or no?
Yes, sir.
So deviation is a concept that you have to use in many cases, in case of refraction, and it may be in case of a curved surface also, in flat surface. So deviation is simply I minus R or R minus I. You can take a modulus. Because if it is a rarer medium, then R will be more than I, correct? So it could be anywhere. Okay, so we'll see something different, something called the next concept, total internal reflex. So we know this is called famously TIR, and perhaps this is the only way to transmit energy with 100% efficiency, and every interface can exhibit this property if the light ray is going from denser to rarer medium. So there are some conditions for this to take place. So first of all, if you have any medium, and if the surrounding is rarer compared to the medium itself, so mu denser, let's say some medium is also here present to make it a generalize. So we know that when the light ray goes from denser to rarer medium, it bends away from the norm. So one thing is clear that this angle will be bigger than the angle of incidence, which means to bend by 90 degree, the eye should be less than 90 or equals to 90 or more than 90. To R to be 90, the eye should be less than 90 or more than 90 or equals to 90.
Sir, I should be more than.
I should be more than 90.
Sir,
See,
what did you ask?
you can see the R is bigger than I because you're going from denser to rarer.
Yeah, yeah.
So to, let's say, to turn the ray away from normal by, let's say, 60 degree, the I we need is less than 60.
Yeah,
Yes or
let's,
no?
sir, by mistake I told you.
So to turn the ray by 90 degree, how much I we need? Less than 90, na?
Yeah, sir, less than 90.
So we can say that at one particular angle, which we are going to say as critical angle, the angle which is just needed to bend the light ray by 90 degrees, the ray will go this way. So this is called grazing emergence. This is called grazing emergence. Okay. I hope this is clear. So now the question is, what happens if the angle of incidence is more than critical angle? So what happens if the light ray is incident at an angle which exceed the critical value? And definitely because it is exceeding the critical value, we have no choice. So the law of refraction will stop. Rather, again we'll go back to the laws of reflection, and this light ray will turn back to the same medium. And the interface will act as like a pure mirror, a mirror with 100% reflection coefficient. So any energy which is incident at any angle more than critical will always suffer reflection instead of refraction. Because we have seen that the final emergence, the maximum angle that we can have in refraction is 90. So there is no point in going beyond 90. Okay. The moment the light ray will incident at an angle which is more than 90, more than critical, the light ray has no choice but to come back to the same medium. But coming back to the same medium is called reflection. It is not refraction. So beyond 90 degrees, we don't use the Snell's law. Okay. What we use is the basic laws of reflection. The light ray will come back to the same medium, and the interface will act as a reflector instead of transmitter. Okay. So it will not transmit the energy. So the energy, if I say the intensity of this light is I naught, this will be exactly I naught. So there is no reflection property in which 100% reflectivity is observed. This is called 100% reflectivity. That is, all of the energy will come back to the same medium without getting diminished or absorbed by the interface or the bond. So how it is happening? So you can say this is happening because the electric field is totally reversed in this case. So there is a new direction of propagation of energy. So medium is behaving in a way to change the direction of propagation completely. Now, the internal mechanism we are not aware of, but we know it is due to some sort of the induction of charge and creation of the electric field due to that induced charge, and that in turn will change the due course of energy propagation. Okay. So, of course, there are many things which is much deeper than what we know. Okay. Hmm. We need to learn something more about this now. Now, critical angle, before we understand, it is not uniquely defined for the light ray. It is defined for a component of light, because I have already explained that a given medium will behave differently for a given medium will behave differently for different component of light. And when we say white light, we have 7 different components. So we need to learn something called. Okay, shall I mention something there extra? So when the TIR is possible, first of all, TIR is possible only when light is traveling from denser to rarer, means optically denser to medium. Okay. And angle of incidence exceeds critical angle. What is critical angle? Critical. the angle of incidence for which what you can say the emergent ray grazes the interface, which means it is refraction and we call it grazing emergence. It is coming out actually parallel to the boundary. So that is these are the things which we think about in terms of definition. So we have something called Cauchy's relation. So Cauchy said that the refractive index of a component of light varies with wavelength, and A and B are some constants depending on the medium property. So you can see as the lambda will increase, the mu will decrease. So a given medium will behave as will behave differently, you can say, for every component of light, and the mu will change
So
accordingly.
what is A and B and
A and B are some constants. And of course, it's a lengthy term actually, which you can ignore as of now. You can just call it A and B are some constants. And you need not to worry about it. It will be given to you in case if it is required. So if they need, they will give you. Okay. Now, the refractive index is function. So now we can find the critical angle for one particular component of light. So we cannot write the like Snell's law for the white light. We can write the Snell's law only for the monochromatic light. So we write Snell's law for monochromatic light. Because the moment you write the formula mu1 sin I is mu2 sin R, the mu1 mu2 is only defined if it is monochromatic. If it is polychromatic, then we cannot define uniquely. So we cannot write a Snell's law for polychromatic light, and that's why we never write it for the white light. So what do we write here? Because we are going from denser to redder medium. And if we talk about the critical angle, you can write Snell's law here as mu denser sin critical equals to mu rarer. And what is the angle of refraction? 90 degrees, correct? And here the sign of critical angle turns out to be mu rarer upon mu denser, and that is logical because sin theta must be less than 1. So the denominator must be bigger value, and that's why even in case if you forgot the relation, think like this. So sign of critical we write as 1 upon mu relative, and which is basically mu 1 with respect to 2. What is 1? 1 is the source of light, like where the light begins, and 2 is where it gets refracted. That's how we write. And what is the definition of mu1 to? Mu1 by mu, right? Is this clear, guys? How we are writing? So what you can see that if mu2 is air, then sign of critical will be simply 1 by mu. That's very simple. If the rarer medium is air, the critical will be simply inverse of the sign of critical will be inverse of the refractive index. And this formula is something which we use very often. But if you have two medium, always use the relative in which you divide the denser with a rarer in the denominator, like this. I hope this part is clear. Now the problem is the mu itself is the mu itself follows the Cauchy's relation. So as lambda will increase, what will happen? As lambda will increase, this term will decrease, and if this will decrease, then this will decrease, which means inverse will increase, which means critical will increase or decrease.
The decrease.
Okay. Think again. What will be the effect of increase of lambda on the critical angle?
Sure, it will increase.
Yeah. So we can draw something a line, and let's write a wave here. So when you go from left to right, lambda increases, correct? Hello, hello, hello.
Yes, sir, and frequency decreases.
Yes, sir.
And if lambda will increase, then the critical angle will also increase. So if you go from left to right, the critical angle will how you can see if lambda will grow, then the denominator will decrease, actually shrink. And as the denominator will decrease, the inverse will increase, which means critical will increase. Correct? Is this clear, guys? Hello, hello, hello.
Yes.
So which one will suffer the TIR easily? The violet or the red or the green
Red.
or the yellow? Okay. So the easiest one is for so which, yeah. So as you go from left to right, the violet to red, the critical angle is increasing. It means it is more difficult to suffer TIR now because we need more angle of incidence, right? Okay, for which color the angle of incidence is least? Simply tell me, yaar, what is the critical angle for violet? The least or the max? Hello, hello, am I audible?
Yes, boss.
I'm asking something, please do answer. I'm asking that for which component of light the critical angle is least
With sorry, V violet.
and maximum?
Maximum rate.
So the easiest one is violet, we say, and the difficult is the red.
Red.
Now imagine that we have an interface and there is a white light which is coming. Look at this question. So let's say this is the white light. Okay. Now you can see the green light is tracing the interface, grazing the interface. So this is a critical angle for which light, which component? This
Yellow.
represents critical for the. This is the critical angle of which light?
So
Tell
for
me.
white light, we take average.
Pardon. See, white light is coming, but green is suffering the refraction, like this, as shown in the figure. So this angle of incidence represents what? Which I think you are not getting it.
So what did you?
First of all, am I audible to you? Yes or no?
Yes, sir.
So answer simple question. A white light is coming from denser medium, hitting the
Yeah.
interface, and then out of all the light, only green is shown. Rest you have to guess. So the green goes like this. So which light will reflect and which will reflect? You have to answer.
So yellow, orange, and red.
Will
They will reflect.
very good. Yellow, orange, red will reflect. Eh? Why?
So we saw that uh,
So the critical angle for the green.
red was able to do total internal reflection better.
Better. I think you are learning totally in a wrong way. I don't know what you're doing right now. Read this carefully. I mean, you're not able to read something. Eh? It's written in English. Increases. What does it mean? The critical for the yellow will be more than green, right?
Yeah, yeah.
So which component will have the lesser angle than green?
Blue.
Blue
All,
indigo violet.
yeah. So all VIB will have the critical angle less than the green. It means the critical of the green is more than critical of these three.
Yes.
If the white light is incident at a critical angle of green light, which means it has already exceeded the critical angle of VIB. Yes or no? Okay, you are not getting anything. I mean, you're totally confused, I think, about this. You read this carefully first, this page. Take your time.
No.
Understood? See, you're not getting it. The white light is hitting the interface at critical angle, which is meant for green light. So at that angle, green will graze, I mean, emerge at grazing, okay, emergence, whatever. So the violet, indigo, blue will have the angle of incidence less than that angle to even do the same thing, which means the theta c of green will act as extra an angle exceeding the critical of these three. No idea.
So blue, indigo, violet will reflect.
So violet, indigo, and blue will reflect by the same angle because it is a reflection. So VIB will come together on this side. But the yellow, orange, red will go on the other side because they are, this angle is not sufficient to suffer the TIR for those components. And among that, the red will go maximum. So sorry, the yellow, orange, and green. Sorry, what I'm saying, yellow. Let me do this. Yellow and red. And then PI. So green is suffering. Na? This is the critical is given for green. So we haven't achieved the critical of YOR, which means it will go on the other side. And yellow will go max. Yellow, orange, and red. And because the refractive index is different for all the components, so the angle of refraction will be different. Understood? And the red, the angle of refraction will be least for the red because red is having the least value of mu for a given medium, right? So lesser the mu means lesser the deviation basically. So if the mu is less, the deviation is less. So this will be the final picture of white light coming at an interface. Is this clear?
Yes.
Yes or no?
Yes,
Are you sure?
yes,
Because
sir.
you guys are, why you're too much confused? Like you're not getting the idea of what is critical angle.
No, sir, now I got.
So you have to be very careful in answering. First of all, the Snell's law is not for white light, it is for monochromatic light. The first thing you need to remember. And once you remember, you can play with the idea. Okay. So let's do some problem. So if I call this as I, let me just complete this. So can we say I is more than critical angle for VIB and I is less than critical angle for YOR and I is equals to critical angle for green. It's given in the question. So the TIR only occurs when I exceeds the critical angle. So these will suffer TIR refraction. This is also called refraction, but we call it grazing emergence. Understood?
Yes, sir.
We can have TIR for the parallel slabs. TIR for parallel. If you remember, we have talked about that for parallel slabs, the Snell's law can be written for between any two surface, right? And it need not to be consecutive. So imagine if we have a four slab, one, two, three. And the refractive index is given as n by 2, n by 4, n by 8. Okay, so this is given to us. Imagine. So maybe you can take. So first of all, tell me the angle of incidence will be this angle or this angle, the small or the big angle. Which one is the angle of incidence? For this slide. The angle of incidence is the big one or the small one?
The small one.
The small one is the angle of incidence, right?
Yes.
So how we draw the normal?
Perpendicular surface. Okay.
So the interface is here now. This is the interface.
Surface. The first surface.
So for first surface, this is the interface. So your motion is going to be this way, na? The light ray will travel this way. So the normal will be this one. Understood? This is the angle of incidence. First thing we need to learn is the direction in which a refractive index varies is called the direction of normal. First of all, in case if you get confused, remember this number. Okay. So the angle of incidence is what? This one. Let's call it theta. Not. This is a medium one. If the incident ray suffers TIR due to medium 4, then find n. You got the question? So if you draw the ray diagram, so it will the light is incident like this will bend towards the normal. Then will it bend away or towards the normal? Tell me guys. No. And it suffers TIR like this. So what is the n value? You may get inequality. So can we say that this angle of incidence must be more than critical for medium, for and air.
Sir, N over here is the thickness or the
The refractive
refractive
index.
index.
This is Ri. Okay. So the simple thing is you can write the distance law between, as I said, you can write the distance law between any two surface. And if this is theta, so we can write the distance law till we have the reflection. So if you write the this angle and this angle, you can say 1 sine theta naught must be equal to mu 4, which is right, sine theta. So the sine theta turns out to be how much? Sine theta naught by mu 4. Okay. And what is mu 4? N by 8, right? And we know that theta exceeds critical angle, which means sine theta will also exceed sine theta c, which means 8 sine must exceed sine theta c. What is sine theta c? Sine theta c is the critical angle between the medium 4 and the air, which is how much?
The
1 by n by 8. Yeah. So maybe they're asking theta now. Yeah, right. N will cancel out. I think they're not asking n. You may need to find the theta now. So sine theta naught must be more than. Oh, this is coming. What am I? Something wrong. This should not be the question. Enters. Okay, this is question from JEE Advanced. Let's see the question. I mean, don't remember the question. Maybe I have messed up with the question itself. We'll go to the JEE Advanced question directly. So you have the 40 years question.
Yes.
Open it. Open it.
Which question?
You can see there's a fourth slab question, and it must be something like this one.
Sir, problem.
Got it? What was the question? Yeah, I got it. Yeah, this is 2008 question. Question number 2008 question number 47. You got the question?
sort of HC or no?
No. Just
Sir, initially, what did you say to open?
41 years. Oh, just a minute. Let me see. So you can see the question 47. So there are three questions that you need to solve, 57, 50, and 55. And this is slightly different question. Something like this one. Let's see. So just misses the medium means it will graze the interface, right?
Yeah, sir.
Then
90
you can write
degrees.
the, you can just write the distance between the first and the last. You will get the answer there. So it will be sin inverse 1/8, right?
Sir, 1 by 8. Yeah.
That's simple formula. And then solve the next question. Question number 50 and question number 55. What's the answer for
So,
the other two?
so the 51, what is, can you solve the 51?
51, why are you solving? You have to solve 50. 51 is
Yeah, 55.
length. So in case of TIR, as you reach the critical angle, the transmission will be 0 and the reflection will be 100%. Correct. So
Yes.
if you read the graph, a light ray traveling in a glass medium is incident on a glass air interface at an angle theta. The reflected and transmitted intensities both as a function theta are plotted. Okay. So when theta is 0, the transmission will be how much? For normal incidence, the refraction is it 100%?
Here will be
Okay. Whenever you have an interface and the light ray is going this way, that's question given, right? This is the angle of incidence. Okay. So as theta will increase, first of all, for any theta, every interface will transmit and reflect. So no matter whether it's transparent or not, every interface will have some refraction. You can say majority of a refraction, but minority of reflection is always there. So there is nothing like 100% transmission. So transmission is always less than 100%. So what we can say, transmission will be less than for any angle of incidence. Okay. So if you look at the graph, in which graph they forgot to mention. Okay, which one is this written? So the transmission cannot be touching the 100% axis. Okay. So in which graph the transmission is touching the 100 will be wrong. So the graph number B is incorrect because the transmission at 0 they have shown as 0, which is not possible. Transmission never reaches the 0. Clear so far? But of course, at a low angle of incidence, the reflection will be also very small, closer to 0, but not exactly 0. Now, as theta will grow, the moment you reach critical angle and the moment you exceed this, the reflection will be 100%. So what is the transmission? So the moment you exceed this, you have 100% reflection and 0% transmission. So in which graph at some critical angle, the reflection is reaching the 100%? Can you see? In which graph it is reaching 100% and transmission to 0%? Which graph? The bold line is T graph, transmission graph, and dotted is the reflection. And
So,
at
sir,
critical,
what
at
are we looking for?
pardon,
What are we looking for?
the correct graph.
So,
We
no,
have
where the transmission is 100.
see, transmission cannot be 100 in any case because there is no interface in which we can have 0% reflection. So even if the light ray is hitting a transparent surface, it will reflect for some value and transmit the remaining value, which is, you can say majority will be transmission, but a very minor value will be reflection at the same time. That I have explained in the chapter of mirror only, that every surface is a mirror, if you remember.
Yes, sir.
Every surface is mirror. Now the thing is, when you look yourself in water, the reflection is less than transmission, so you see a dull image. But when you see yourself in a mirror, we have more reflection than very poor transmission, so we have a brighter image. And TIR is the phenomena in which the reflection is 100% and we have 0% transmission. If you plot the graph, and if theta will grow in this direction up to 90 value, so at a 0 degree of incidence, if the light is going this way, still some part will reflect back, but majority will go this way. So I can say that transmission will be just below the 100
Yes, sir.
and the reflection will be just above the 0, not exactly 0. Now at critical angle, the transmission will completely vanish to 0 and reflection will exactly become 100 like this. Understood? So the dotted line will merge with 100 line and the bold line will merge with 0 line. And if you look carefully, this graph is properly depicted in
See,
C.
sir, but then D, what is wrong in D?
In D, it is not reaching, it is reaching 100% slowly, but it will
Yeah,
occur at one particular angle, not at multiple angles. You can see the dotted line is moving towards 100 at infinity at 90 degree, but this will happen before 90. Na? This entire thing will achieve at critical only, na, this angle. Just next to critical, everything will be achieved, isn't it?
yes, sir.
So it will not occur slowly, it will occur only at this angle. It will just
Yes, sir.
go to 0 and go to 90 at the same time. Let me do the this minus bold, the R. So that is wrong with the D option. Okay. And why B is incorrect, I have explained. Same is with A also. It
Yes.
is now solve 55.
For 55, I'm not understanding what the light ray is exactly doing.
Okay, let me give you a simple question before this. Not this question only. So when we have a source of light, let's say we have a source of light at the bottom. So this source of light will emit, will emit light in all directions, right? So light ray which is going this way will simply come out like this.
Yeah.
But the light ray which is going this way will bend away from normal.
Yeah.
But there is one particular light ray which will simply graze the surface,
Yeah.
and beyond every other light will come back. That's the whole idea. So this must be the critical
So,
angle.
so when they're asking that the image like is formed on top of the block, a circular bright spot. So
Yeah.
why
So
is it happening?
if you look from the top, the light emitting area will be how much? Can you see the light emitting area from the surface? You don't see this. Huh? From what area light will come out? Tell me. Can you see?
Yeah.
In surface, from all the conical direction, the light will come out, isn't it?
Yeah. Yeah.
And rest part will be dark because light is not going on the other side. No?
Yeah.
So what you see? You see light. So you can see the light will only go up to the critical angle value. And beyond critical, anyway, light is not coming out of the surface. So given the depth of the pond, let's say h, and knowing that theta c, you can find the radius of this disk, correct? Hmm?
Yes, it's given once.
So now you can find that tan theta c is how much? R by h. R is h tan theta c, which you can write as R sine theta h sine theta c upon cos theta c, which I will write into sine term. Why? Because we know the sine of critical angle, 1 by mu, correct?
Yes.
So the R turns out to be 1 by mu upon 1 minus 1 by mu square, which will give me answer this much. The area of this will be how much? And what is the solid angle? So what fraction of light we can expect it will come out of the surface? The fraction of light coming out of surface will be how much? Omega upon 4 pi. Correct? That's how we define the fraction, because the net light coming is to 4 pi angle, out of which only a fraction will come from here. So this fraction you can calculate somewhere here. F equals to omega by 4, which is, and the cos theta is how much? You know the answer. So these are the questions that you can probably get from the TIR. And I think the question 55 is similar to this only, right?
Yes.
So now you can solve.
Yeah.
Do it.
Sir, I got it.
Okay. I think answer is 1.21, no?
1.36.
36. So I haven't checked the answer. You can check.
Sir, I'm getting 30 degrees. So
Okay.
half into 2.72.
All right. Okay. So there are many questions that you need to solve. I mean, what I'll do is I'll share some questions, and anyway you have the question. 41 years is good. So you can solve the previous year JEE question, all the questions so far. And with this, I'll solve next class. I'll solve the optical fiber question, which are very important for JEE. And With that, we'll be finishing the refraction from plane surface, part one. So next we'll enter into prism, concept of prism. Okay. Okay. See you in the next lecture.
Thank you so much.